2,000 years ago, the edge of the world had a name, Ultima Thule. Ancient maps treated it as a literal dead end, a place where the ocean froze solid and the sky dropped to shatter against the ice. Sailing toward it meant leaving human comprehension behind. Mariners believed crossing this boundary meant surrendering to a dark, freezing void where nothing ever returned. But in 325 BC, a Greek geographer named Pytheas of Massalia decided to map it anyway. Leaving the warm, predictable currents of the Mediterranean, Pytheas steered his ship past the Pillars of Hercules and headed due north, straight into the lethal, freezing waters of the North Atlantic. He returned with highly specific data, yet instead of being celebrated, his expedition was buried. The facts he recorded were twisted into a terrifying ghost story that paralyzed explorers for centuries. Pytheas documented his entire journey in a manuscript titled On the Ocean. In it, he described an island located a 6-day sail north of Britain. We don't have that original manuscript today. The physical text was lost to time. What we do have are fragments, quotes lifted by later Roman historians. Scholars like Strabo and Pliny the Elder wrote about Pytheas mostly to mock him. They read his descriptions of this northern environment and dismissed him entirely, labeling him a fabricator of absurd fairy tales. This created a clash between two entirely different ways of looking at the world. You had a field researcher taking precise astronomical measurements, judged by armchair scholars who refused to accept data that contradicted their own comfortable environment. To figure out what really happened, we have to look closely at these supposed lies. We must determine if Pytheas was hallucinating or if he simply walked into a climate that the Mediterranean mind literally lacked the vocabulary to describe. Our first piece of evidence is the environmental shock of Thule's climate. Pytheas reported an environment operating on impossible rules. During the summer solstice, he claimed, the sun never actually set, leaving the landscape trapped in a permanent golden twilight. To a Greek, agriculture meant clear skies. Back home, grain was harvested and threshed outside, beaten on open stone floors under a blazing sun. But in Thule, Pytheas observed tribes doing the exact opposite. Because of the freezing, endless rain, the locals had to drag their wheat into massive, dark timber longhouses to thresh it indoors. The Roman scholars reading this account flat out rejected it. To them, farming inside a wooden building was a contradiction in terms. Plants needed the sun, and the idea of hiding crops from the sky made zero biological sense to a Mediterranean academic. Yet what Pytheas documented was a perfectly rational subarctic survival strategy. The absurdity lived in the geographical bias of the people reading his notes centuries later. The real trouble for Pytheas's reputation, though, came from a phenomenon he called the sea lung. As his ship pushed further north, he hit a barrier where the ocean, the air, and the land seemed to merge. He described it as a gelatinous mass, a suffocating mixture where a person could neither walk nor sail. For the next 2,000 years, historians laughed at this specific paragraph. They pointed to the sea lung as obvious evidence of madness, writing it off as a magical obstacle invented to scare sailors. But if you map his ancient Greek vocabulary onto modern marine physics, the magic disappears. Pytheas was describing dense Arctic sea fog settling heavily over a shifting slurry of pancake ice. He didn't invent monsters. He was a scientist standing on the bow of a wooden ship, trying to document the extreme Arctic Ocean, using the language of a society that didn't even have a word for icebergs. Today, the armchair historians have been replaced by modern science. We now have the tools to test the conditions Pytheas actually sailed into. This chart maps paleoclimatology data from deep-sea core samples, tracking ancient weather patterns. Looking at the specific parameters of the North Atlantic around 325 BC, the physical data plots perfectly onto the fictional environment described in the lost manuscript. Meanwhile, physical marine archaeology continues to pull evidence from the frozen ground, proving that agricultural tribes were surviving and working in these extreme northern zones, exactly when Pytheas said they were. Ultima Thule was a triumph of empirical science. This journey reveals at the edge of the world is a shifting limit of perspective, one that eventually yields to the clarity of observation. For over 2 millennia, the story of Pytheas of Massalia was considered one of history's great tall tales. He claimed to have sailed an ancient Greek vessel so far north that he reached the edge of the world, a place called Ultima Thule, where the ocean itself was swallowed by the freezing unknown. Prominent Roman scholars openly mocked his accounts, but their skepticism was entirely theoretical. The historians who branded Pytheas a liar were men writing from warm Mediterranean villas, debating literature rather than navigating Arctic waters themselves. Recently, that entire historical framework has been discarded. The search for Thule is no longer in the hands of classicists. It is being led by marine geologists, glaciologists, and oceanographers. This thermal model displays the North Atlantic sea ice extent. By applying advanced paleoclimatic modeling to historical datasets, researchers can reconstruct the exact weather patterns and freezing conditions that existed off the coast of Europe around 300 BC. By analyzing the physical environment of antiquity, researchers are removing ancient biases. We are testing a classical legend against hard, measurable Earth science. The most fiercely criticized detail in Pytheas's journal was his description of the sea lung. He reported reaching a point where the air, water, and ice blended together into a sluggish, impassable barrier. To ancient critics, this sounded like outright fantasy. Modern sea ice physics tells a different story. When a turbulent ocean surface becomes supercooled and interacts with heavy, freezing Arctic fog, the water behaves in a highly unusual way. It creates a specific phenomenon known as frazzle ice, which rapidly clumps into what we call pancake ice. The freezing ocean thickens into a heavy, gelatinous slush that restricts the movement of a ship's hull, exactly as Pytheas described. This ice core, extracted in 2026, holds the stratigraphic record of those historical temperatures. The data clearly shows that this exact type of volatile freezing pattern was highly active off the coast of northern Norway during the 4th century BC. The sea lung was real. A Greek navigator accurately documented a hyper-specific climatological event centuries before the scientific vocabulary to explain it had even been invented. Establishing the climate is one step, but we also have to look at the land. Following the navigational coordinates left by the expedition, archaeologists recently focused their attention on the island of Smola off the central Norwegian coast. Pytheas noted something that baffled his contemporaries. The inhabitants of this northern region brought their grain inside massive structures to thresh it, shielding it from the damp environment. In the sun-drenched Mediterranean, where threshing was strictly an outdoor activity, this sounded absurd. The 2026 excavations revealed exactly what he saw. Digging beneath the coastal topsoil, archaeologists uncovered an extensive network of large structural post holes. Using ground-penetrating radar on this footprint, researchers mapped an enormous early Iron Age timber longhouse. The interior divisions show a fully enclosed area specifically built for processing crops. Once again, the physical evidence aligns with the text. The subterranean blueprint proves he was documenting genuine agricultural practices necessary to survive in a hostile, freezing climate. Finding the right weather patterns and the right buildings still leaves one critical gap. Proving that the environment matches a description does not automatically prove a Mediterranean explorer physically stood on that soil. Evidence for a Greek presence in the Arctic appeared within the deepest layers of the Norwegian excavation trenches. As the team sifted through the frozen mud, they uncovered an artifact that did not belong in the North Sea. They extracted authentic bronze coins dating precisely to the 4th century BC. This physical metal directly links the remote Arctic coastline to classical antiquity. Analysis confirmed these specific coins were minted in Massalia, the exact home city of Pytheas. They were buried alongside fragments of terracotta Mediterranean stories vessels. This physical evidence answers the final question. It places Greek artifacts on Norwegian shores thousands of years before the Viking Age, verifying the earliest recorded maritime connection between southern Europe and the far north. The sea ice data, the structural foundations, and the recovered artifacts all point in a single direction. Independent scientific disciplines have converged on the exact same conclusion. A highly organized expedition from ancient Greece successfully charted the punishing routes of the North Sea. The maps of classical exploration must now be expanded outward by thousands of miles. Ultima Thule was a harsh, freezing frontier, mapped by a navigator who followed the coastline to its physical limit. Pytheas was not a storyteller trying to entertain an audience. He was an empirical observer. He carefully recorded weather phenomena and agricultural practices that were simply too accurate and too strange for his own contemporaries to understand. The waters of the North Atlantic now serve as a record of genuine achievement. Pytheas's observations have transitioned from disputed myth to verified history.